And I think Nicolas is already here in the room. And then we also have one of our colleagues and also Nicolas' colleague, Bjørn. He will join online today, but then you will see him very soon because I think he has a meeting in Leiden, different city in the Netherlands, so can't be here locally. So in that sense, Nicolas, maybe introduce yourself, and then so we can then enter in the third kind of theme of the today.
All right. I'm using the room microphone, so I hope everyone can hear me fine online and everything. So my name is Nicolas. I'm one of the data stewards at TU Delft, so I'm here to assist researchers with the data management, so data acquisition, collection, storage, a bit about processing the tools that we have available, and a little bit about publishing things. So open science, kind of data publication, data management, that started to grow a bit in importance over the past few years. So it's worth kind of spending a bit of time thinking about what we have to do and how we can get organized. I could almost start the presentation right now if you guys want.
Yeah, why not? Yes, we can. Yeah, because I think the plan is that we continue the flow.
We need to share the slides.
Yes, I'm on Zoom, so I'm going to share my screen.
That's the presentation work. Yeah. Okay, let me make you co-host. That you can go ahead.
So it's a bit awkward, so because Bjørn is slightly somewhere else, so he's trying to do. He'll try to connect in a few minutes, I guess.
Yeah.
Well, on the other hand, I have to be at 12 at the TU Delft library for another event, so.
So that's fine. You do this in the combination.
So I don't mind starting a bit earlier than expected.
That will be nice for you also.
All right, let me get to Zoom, and I will share my screen, and we'll get going.
Yeah, I don't know why nowadays when we do this online meeting, do we find the Teams and Zoom, which one is
Zoom? Definitely. I could not transfer to Teams for some reason. I prefer Zoom.
Oh, for Zoom. Okay.
Yeah.
I think video and also the streaming experience wise, Zoom is for me more fluent.
Yeah.
Personally speaking.
I'm used to the interface as well, so.
Yeah. Okay, yes.
All right. I think you can see the screen. Disclaimer, I'm on Linux, so that's probably why you don't see the entire slide. It's It's about interoperability of systems and data.
And we are recording this. Hopefully that's okay for you.
Yes, this is fine. And if you want the slide afterwards, I'll be happy to share the presentation, so you can have that for reference if you're interested.
Thank you.
Yeah.
So the idea of the presentation was that, so I was going to talk about hardcore data management, annoying concept, and then Bjørn would come in and start to talk about the exciting open science dimension too. So I'm going to start right away, and we're going to start with data management. And I kind of wanted to use the type of, data management for me, open science for Bjørn. You're welcome to ask questions at the end, but if you have anything to point out, I think we can afford the time for you to interrupt me and ask questions. This is quite fun. And so we have a little catchphrase, so science is like a parachute, and it's open, it's faulty. It's lovely, it's maybe a bit exaggerated, but it illustrates the philosophy behind. So data and research material. So we would love all the research material to be organized, where every place has a thing, everything has a place, and we know what is where, and everyone can use it in an elegant manner. When it comes to physical equipment, it's pretty easy to understand how we could organize maybe the books in the library or the sample in a shelf, but when it comes to digital environments, we're somewhat a bit less cautious about those things. But research data is a shared resource. And it's located somewhere, and it should be accessible to some people. There's not that many cupboards in a lab that are accessible to 100% of the people working around in the university. There's always some kind of access control over that. Not everyone can take whatever they want from the labs. And the important part here is the shared resource. So as part of a research project, it's always super awkward if people are the only one to have access to research material. So how do I access the thing? Well, you need Bob, and if Bob is not here, you don't access the thing. That is probably not correct. So as a rule of thumb, when you work in a research project, it's always smart to figure out who else will have access to your research material. So that can be for a silly reason, like, well, you get hit by your boss, and then people need to carry on with your work. So they need to know where is what and how to be able to work with it. So again, with the shared, it's pretty easy to see where it's a shared thing. But when it comes to research data, there's a sense of ownership. Like, I created that spreadsheet, this is my type of thing, which is kind of true in practice. But still, it's kind of a joint effort. Just like the cupboard, research material should by default be stored inside the institution. So that relates to the question that was asked earlier about GitHub and what can we store there. GitHub is kind of a shell for software and it's outside of the university. So it can be used under some circumstances, but this is something that requires a bit of forethought as to not uploading everything up there. So when you're working with digital material, so you are in charge as a researcher to find the right storage location and manage the access rights. You may get support from your institution to do that, but technically you know what you have and who should have access to what as part of your project. There are nowadays, and that has been increasing over time, there's more and more security measures, rule on how we should keep things safe. And so it's up to you as part of a collaborative project with other institutions to appreciate that all institutions may not have the same rules. And we have to compose a little bit, and each member of an institution kind of swore that they would abide by the institution rules. So we have to be a bit careful about that. So it means that as part of an ongoing project, when material ends up on Dropbox or kind of free public Google Docs elements, well, that can happen, but the material has to be kind of vetted a bit by everyone. Everyone has to agree that this stuff is benign. So for instance, I've seen a great many research proposals being written on Google Docs because it's still in an early phase and it's kind of the brainstorming part. And if someone steals the proposal from Google, but they still have all the work to do anyway. So it's not necessarily an edge here. So there are things that can be done with those public services that are available for everyone for trying out with benign data. You can experiment a bit. But as soon as it becomes actual research material, then you have to pay more attention to that. And same goes with digital protocol, try to avoid USB sticks, external hard drive for your own backup. So that's something you could do if you negotiated a bit with your IT services to make sure that the hard drive is in the right place and you have a key for it for your research material. And as a general rule, and that comes often as a surprise, your laptop is not considered secure. And that's why you may want your software to be hosted on Git, rather than your laptop, just in case you forget it in a train, lose it at the airport, you spill coffee on it. Those are bad ways of losing data. There are more interesting ones. All right. And then boundaries. So this part is a bit important. So you're working in your workspace, that's where you do your things. And the data that comes in usually from the outside, and you should be trying to keep track of what is what. So trying to keep track of data provenance or the condition under which the data was acquired is becoming more and more important. So if you obtain interview recording based on consent, then the way that you acquire the consent, the type of consent that you got, so the consent form, the template is something that binds you and your participant to what you can do afterwards. So if your consent form, you say everything's going to be private, nothing's going to be said, and you cannot publish a paper. You told everyone you were not going to do it. So we have to keep track of the condition under which you acquire the data. In some more standard situation that relates to non-disclosure agreement, they can be licensed for commercial tool. So for instance, you would download a commercial tool from any company. You want to do open science. You can republish the data, but chances are you cannot publish the tool. It's not yours to redistribute. But provenance is going to be quite critical. This allows us to do transparency. This is also how we can check the legality of reuse. Then as part of your work, when you're working, you often have partners. So we tend to favor kind of collaboration. We want to be transdisciplinary and work together across universities, either in the form of kind of a short collaboration or a large consortium, as it is the case for the 6G project here. There's quite a few people involved. And so here again, the data will move from your institution to a partner institution. So there are conditions as well. Technically, there's a consortium agreement that is often signed by large projects. And all the project partners sign that. The consortium agreement contains information such as, well, the intellectual property, the stuff that each partner is bringing to the project is their property. Everything that you create on your own is your stuff, but everything that is jointly created is the property of people that contributed to it. And those will help us to figure out, like, if there start to be disagreements about what can be done, and as part of open science, what can be published, then having those documents at hand could be quite useful. And more recently, when it comes to privacy, something that I saw kind of slow down project is the establishment of GDPR-related agreements. So if we want to transfer personally identifiable data, that can be audio recording, list of names, transcript of interviews, pictures of people that we use for research, practical for research, then the transfer of those should be framed by the appropriate legal agreement. There's a bunch of those right now, my impression is that different institutions still handle the GDPR legal documents in a slightly different way, with slightly different expectation. And that's one of the reasons why establishing those agreements can take time. It's not so much that what you're doing is terrible from a privacy perspective, is that institutions have to align on what they consider to be reasonable infrastructure and what are the compensation in case of data loss, for instance.
But what do you see actually nowadays? Is it even among different European universities, they have different views on this? Have you seen these cases like that? That's for people working across different universities.
So some of the challenges can come in the level of details that they expect in a document.
Yeah.
So some would like to have things very precise with the exact detail of the data that flies around, while others are fine to have very high-level description of what happens. Those are things that can get sorted out. One of the surprising problems that I've seen a couple of times that really illustrate the type of issues that we can get into is the question of applicable laws. So all the agreements, they have a statement at the end that says, in case of conflict, we go to the court of The Hague. And that's the Dutch version of it. If you work with people in France, they're going to say, in case of disagreement, we go to the court in Paris.
Yeah. Okay.
And so as long as we're working with European partners, that we can say, well, okay, maybe we use the court in Brussels. There's some kind of middle ground. But this is part of the stuff that kind of pops up all the time. And there has to be some kind of agreement. And it's not something that the researcher can decide on. You have no leverage here. You have even no steps in that discussion.
Sure.
Because on average, nothing happens.
Yeah, we experienced the problem in midterm the project with, you mentioned audio at some stage. And it's the auto recording, the transcript, right?
Yeah.
So I think universities were relatively okay to use whatever tools, but the companies were not. And I think at the end, after very long negotiations, we decided that we will only use this transcript tools that come with the software. So for example, for Google Meet, it's Gemini. For Teams, it's their own Teams transcript. For Zoom, it's the own. So we should not use any third party. And this was after very, very long negotiations still, because Ericsson only had one tool that they approved, and it was via Microsoft Teams. So if there was a meeting set up initially on Zoom, they were not happy to use the transcript on Zoom. So we've had, and we never had that in the consortium agreement, because back then, even the tools like 3 years ago, they were existing, but they were not so popular. I mean, the transcripts worked, but they didn't work that well, and now they work well. With the use of AI, so we didn't foresee it at the time of preparing of the consortium agreement. And I think it's, again, like eye-opening, because for the next consortium agreement that I will have in the project, hopefully soon, I will definitely add like a sentence somewhere that this is a list of approved auto description or transcription tools, and everyone has to agree to this. So that's something.
I wonder if this is an information that should be in a consortium agreement, but this is something that needs to be sorted out very early on. So
Yeah,
at the moment
before the project starts, it needs to be sorted out. But unfortunately, the consortium agreement is signed after the project starts. So usually you hit month one, let's say January, and you have a couple of months to prepare the consortium agreement. And in that time, you need to agree on this. Before the project, you don't have space to put this into the proposal, really. So yeah, it's something that needs to be agreed on with the others. It doesn't go into the grant agreement, for example, right? The EU doesn't care about this. It's your internal way of managing things. So especially with the industrial partners, and the bigger the industrial partner is, the worse it is, because they have huge complicated ways to approve anything. Like even printing is difficult in this company. So yeah, it takes time. Anyway, sorry.
No, that's an excellent point, because I think we're still waiting for Bjørn anyway, and I'm rushing through my slides. So that's really valuable. So in terms of time frame, I don't mind expanding on that for a second, because at the moment the project starts, so you get your grant letter and everyone is happy, and then so we start working on a consortium agreement that would set the legal basis for all the transfer and everything else. Those consortium agreements usually do not cover personal data, and they don't cover things like what tool are you going to use through the process. And most funded by now request a data management plan fairly early on in a project. So NVO in the Netherlands, they actually want the data management plan for the project start. If you don't have it, you don't get the money. And European project tend to ask the first DMP within the first 6 months to the first year of the project. I don't remember the exact deadline. But the creation of this data management plan, especially early on in a project, I tend to advise researchers to focus on those things. So especially focused around collaboration, transfer of material, trying to plan ahead for that. And maybe in the future, we'll have consortium agreement that covers privacy and we'll be able to freely exchange personal data on research partners. That'd be brilliant. But legally, for now, it's a bit complicated to set up, I think. All right, and at the end, well, in any case, we want to publish stuff. And what we would like to publish should be free of personal data. It should be free of confidential information. And we should indicate where we got our data from. And that's part of the open science dimension. Bjørn will cover that a bit more. But the idea is that we have to be a bit transparent. So in a sense, I'm not quite sure exactly how Bjørn is going to talk about that. But if you get data from initial partners, you cannot republish it for sure. And I think it's fair as part of research practices to say, well, I got my data from this industry. This is the type of document that I had to produce in order to obtain it. If you want to get the data to rerun my experiments, follow their protocol. But then we have to be a bit explicit about what protocol we went through and how we got it. All right. Sharing is caring. So indeed, data transfer are one of the big things. I kind of got ahead of myself, but indeed keeping track of data provenance, keeping track of the legal framework under which the transfer was done, even if it's just a consent form, but things like joint controllership or processing agreement for GDPR, even having access to the consortium agreement for the project member is kind of useful. At TU Delft, because of the many different types of collaboration that we have, the ethics committee will occasionally ask us to justify the state of our collaboration with our partners. So if we're going to work intimately with them, or if we are going to outsource some of the responsibilities with respect to human participant, for the ethics committee, they would like to know that the collaboration is set in a formal manner. So we end up with a kind of PhD student that suddenly hunts around for a consortium agreement. I don't expect PhD students to read the consortium agreement and to know everything what it contains, but it's something that is interesting for them because that kind of frames their activity. So knowing where that is and maybe have a quick look, having access to that can be valuable. It's interesting to discover how intellectual property is described in those documents. When you're going to transfer data, try to use the appropriate tool. So we have something at TU Delft called Surf-Sender, but as we've just discussed, pretty much every industrial partners have their own stuff. So that can raise occasionally a bit of tension when we want to exchange sensitive material with an industrial partners, and then TU Delft says, our policy is to use Surf-Sender. Well, our industrial partner says, our policy is to use Microsoft Secure Transfer, with the authenticator. And then we have to come up with some agreement somehow. I'm tempted to say that in my limited experience, usually the industrial partner will win this fight. Because if it's safe enough for them, it should be safe enough for us. Again, try not to use USB stick for data transfer. This is something that happens. It's just create multiple copies of data that is potentially a bit sensitive, so try not to use that. And the fact that we have to document provenance kind of says that unofficial data, stuff you find in the corridor, stuff that you got from your colleague at the coffee machine, that's not really a way of acquiring data anymore. This broad, trust me, the data is good, is something that we cannot really do. Occasionally, this is frustrating because we have people who have great data and would love to work with it, but then we have to be able to talk about where we got that data from and kind of enable others to access it. Discussion at the coffee machine are hard to reproduce. So start the discussion early on. The slide is cropped, but well, I think the rule of thumb when it comes to large collaboration is about figuring out who's going to say what. And the idea is that the data provider, the people that have the data, they are the ones who are supposed to set out the requirements. It's my stuff. I tell you what NDA you have to sign. I tell you what GDPR agreement you have to sign. I tell you whether the consortium agreement is sufficient or not because it's my stuff. On the other hand, the people who request the data are supposed to raise flag and are supposed to ask for those rules. Otherwise, what happens is that the people who say, we're supposed to receive data and you didn't say anything. And then suddenly there's a rush halfway through the project because then we discover what type of agreement needs to be done. So if you are expecting material from partners, it's up to you to raise your hand and make sure that you are known, because the data owner, they already have it. They don't care. So to avoid delays, it's really about identifying early on who needs what and who has what, in order to make sure that we kind of raise the flag early on so that the paperwork can be done. Very well. So I think with that in mind, the rest of data management would be something like I'll tell you how to organize your GitHub repository, which is something you should be fairly comfy with. I don't feel the urge to tell you how to create folders and document your code. If you're using Git, you know how to write a README file. I'm fine with that. But then there's this kind of little thing, this sense of ownership of data. And for young PhD students, probably not a problem just yet, but as you carry along in your career, there's a chance that you will switch institution. And so the data you've created, even your code, is not your property. It's not legally yours. It belongs to the institution that employs you. In the Netherlands, PhD students are employees. So the stuff they create belongs to the institution. I don't know what is the detailed status in France, where PhD students are actual students and they have their own scholarship and so on. So that's probably a bit different. But the general idea is that your research material is not yours. So when you are changing institution, if you finish your PhD and you say, well, now I would like to carry on with the work, what material do you need and what would you like to take out of your institution? And is that okay or not?
Also at the undergraduate level, whatever you produce, at least in UCD, is technically a property of the university. So, for example, if you create some code, you submit this as part of the assignment, or maybe you do your final year project, before you exploit it further, usually UCD doesn't make big fuss about this. You have your master project, or you had your final year project, and you think, oh, this is a great idea. I will take this and create a company from this, or create a bigger product from this. Usually they don't care. But when that company grows really big, there may be a possibility that UCD will knock and say, hey, by the way, you've generated this content while you were studying here, so we want 5%.
So that might be different from Delft, right?
So for master students, what I know is that when they are working internally, so their work is not part of an internship, it's not part of a European funded project, there's actually a certain amount of fuzziness about intellectual property and who owns what. Yeah. Because it's a highly creative process. They kind of pick the topic, they kind of decide the method, and then they are guided through, but it's a creative process, and they will own most of the intellectual property of the work. But you therefore still have something, because we contributed to it in terms of supervision, access to the bathroom, the data stream that help the master students. And so this tiny percent is not necessarily described. Yeah. And so that's why I advise students to say, well, if you are about to do something awesome and you want to turn it into a company, you're aware that there will be support at TU Delft. Try to go through TU Delft because they know exactly who wants what. However, the master thesis itself, that's copyrighted to the student, that's their stuff. And then they agree to make it publicly available on the TU Delft library. I haven't seen any students say, no, that's my stuff and I don't want to share, but technically they can, because they're manuscript. So
they can reject the open publishing of that thesis.
Yeah, I think they can probably make a reasonable claim, and then that's going to be challenged by the policy of TU Delft that says that all master studies should be published, and that would lead to an interesting discussion. Right. And I'm not sure who would win, and I'm not sure who would really care, depending. That will really depend on the thesis itself. But so the things that you may want to keep at the end of the project to carry on the work in another institution is something that has to be planned in advance. And the more challenging things that I've seen is when people actually arrived at TU Delft with material coming from somewhere else, and that actually contained personal data or it contained confidential information that was gathered in previous stages. So at that moment, what happened is that you may try to go through internal legal processes, and question about where does that stuff come from will pop up. And that's going to slow the process to a grind, because as soon as there's some ambiguity about who is supposed to own what, from a legal perspective, ambiguity is not really acceptable. The answer will be, well, try to figure it out, and then we'll make a decision once we've agreed on who owns what. This is also a moment where I can take the time to raise the flag about this idea of joint ownership of material throughout project. it's great that we're working together, but if we generate output together and it's considered to be a joint ownership, well, technically we need to agree for, like every time we want to do something with it, we need the agreement of the co-owner. And so if, I don't want to spoil Bjørn part about open science, but one of the answers will be, during the project, the co-owner should agree to make it publicly available. Because then suddenly, both owner or everyone involved in the ownership of the stuff has agreed that it should be available under a specific license, MIT BSD for software, CC by SA for data, but then the decision on what should be allowed on the material has been made during the project, and the outcome is publicly visible and it's challengeable. I mean, there's a clear license. If that does not happen, then it still remains the property of two different institutions all the time. And every time QDF wants to reuse material, we need to call the other university and say, can we do that? And I think in practice, this is something that we don't necessarily do. So we're kind of playing around this kind of fuzzy area of joint ownership of research material. Truth is, most of the time, I think researchers, you guys will talk to each other and you will agree on things. So it doesn't become the massive legal issue, but you will get stuck into it with respect to internal processes. So for instance, trying to reuse material that is co-owned in a new project, you will struggle to explain in your consortium agreement that your background IP is not entirely yours. That can be a bit awkward to write down. Very well. So I didn't really talk about the very technical dimension of data management, about how big your commit should be, how do you manage your team's folder. Because I think that if you take into account the point that I've raised here, that should give you the idea that what matters is going to be the mastery of the flow of data. Control is not quite enough. You really need to know what is where and under which condition, in such a way that you'll be able to make good decisions about what should be published, what should be preserved secretly, and what should be deleted at the end of the project. So if you keep track of all the stuff, making those decisions will still take time. It's going to create discussion, but it should be doable to come up with a reasonable conclusion. And that's roughly where I was going to hand over the things to Bjørn.
Yeah. Okay, easy. Yeah, but I think I really appreciate the kind of the insights you have because you have been dealing with many of the conflicting or controversial cases, maybe also based on the daily experience. Any questions from the audience? Yeah, this is a good time to ask Nicolas because he is actually our data steward in university who has seen a lot of cases and also dealing daily with all the different requests on campus. And then, yeah, time to ask if you have.
Just an observation. So when we started to work on projects and proposals, we all focused, I mean, when I say we, people in the group that are computer scientists, engineers, we focus on the technical content. But the more and more we get higher in terms of, we don't look into the specifics of the technical contributions, but the project overall. So we don't only look at in the implementation section, but we also look at the IP. So who brings what IP into the project and what IP is generated? What are the key exploitable results? What are the commercialization opportunities? And something we never looked at. So legal and business perspective of the project, that is part of the evaluation, right? Because the, for example, for SNS projects or some of the Horizon projects, the really important aspect is there a possibility to exploit these results and maybe create something that can be later sold in form of a product or commercialized anyway in some sense. And I found that, for example, in UCD, I think there is some training, but it's not also like easily accessible. And when you go to legal, you need to go to them with very specific question that you usually can't even formulate. So it would be nice if, like, all the universities, for people that are involved in some kind of projects or proposals, European or local, have some, I'm not saying mandatory, but at least available IP management training, for example. And also for the open science, people are not always very clear on which exactly tools to reach, right? So for example, Zenodo is the go-to for Europe now. Like before Zenodo, we were using like Archive, Vex, all of this. So it keeps changing. It's actually keeps changing really fast. So this is for scientists. I think this is quite hard to navigate field in. When you're thrown in the middle of business and legal aspects, sometimes you just panic. So I think right training again is really important, and there is quite a big importance when it comes to that.
Yeah, Jose, you raise your hand. Speak up, maybe.
Yeah. So some question. I mean, in those projects, basically, we generate these large data sets, and Nicolas explained that we have this kind of rules to protect or like manage the data. So one of the requirements, or I don't know if there are some requirements for observability of the data and how would I say, archiving or logging? Meaning, are there any requirements how long the data needs to be archived, maintained, in case that someone needs to look into that data for, I don't know, legal reasons, for reproducing the research? Are there any requirements for that?
That's a tough question. So ideally, I think we would like to keep all the data forever, but forever is too long and all the data is probably too much. So there's a part, like research material. So where does the requirement come from? Most universities will have a policy that says that they would like to keep the research material for about 10 years. So that would be kind of their internal policies. At least in the Netherlands and probably in Europe, universities are part of public administration, so they have a duty to keep material for the stuff they've done for a while. And then for research material, then especially when you're in humanities or social science or anything with people, then privacy laws would say that you have to keep the material for as short as possible for privacy preserving practices. And those will definitely conflict. So as part of the idea for me is to say whatever we can make public should be archived for at least 10 years, because we're relying on a third party to actually keep the data there. So 10 years should be doable. At the end of the project, everything that was personal, we should keep for at least as long as it will take for the papers to get published and for the scientific community to react. And so this is a bit up to you guys to decide, but usually I suggest about a year until after the end of the project, to try to wrap things up and give the opportunity of people who read the paper to say, oh, but did you really run the interviews? And then we have the possibility to show a transcript or something like that. That opens the question to everything else. So the stuff you haven't deleted because it's confidential or personal, and the stuff that could not be made public. In an ideal world, that should be kept for 10 years for replication and so on. But you get produced so much stuff unless we have a proper archive, and some institutions have that, where you can dump your data and just forget about it, and it will be saved by IT for 10 years. At the moment we have that, I'll advocate 10 years for everyone. But as long as the responsibility of the storage is archival is on the researcher side, and we look at you and say, of course you're going to be safe with all the data you've produced in your career, and then you remember to delete it in 10 years, you're not going to forget, right? So if we provide tools and solutions to actually help you do that, then I'll be happy for Delft to everyone save stuff for 10 years. For now, I would say, look at the data you have, and if there are things that you think are valuable, those you save for 10 years. Everything else, just you should be allowed to forget stuff. I'm more about carefreeness, not carelessness, but being carefree with respect to what happened at the end of the project. You know, you have what you need, everything else you can afford to forget. You keep the good knowledge and the tools and techniques, and forget about the blah, blah. But I think officially most institutions will work with this idea that 10 years is what we aim for.
Okay, sounds good. Thank you.
Okay, thanks. Yeah, given the time, I really appreciate Nicolas coming here to actually share the experience and also the very important subjects, because I know, as Bart just mentioned, that now when people are more kind of engaged into projects, all the kind of legal data management issues will come up, and every time when there is an issue, it's a big issue. So yeah, thanks for sharing the lessons and also insights. Yeah.
Very well. I'll stop sharing my screen. I'll let Bjørn take over because
I think he's online.
I have layout issues, so there's no point in sharing that. And I will let Bjørn take over. And if you have more question about hardcore data management stuff, is the data steward of one of the faculty here, so he knows just as much.
Indeed, great. Thanks.
Have a lovely day. It was a pleasure to be here.
Yeah.
Bye-bye.
Bye. And also, I think Bjørn, you are online now, right? Can you say something so that we can hear? You're muted still.
Yeah, can you hear me?
Yeah, clear.
Cool.
Okay, good. Yeah. So in that sense, yeah, I think now you probably already kind of follow what Nicolas has already presented, and then yeah, now this is also a perfect moment to hand the mic back to you so that you can directly zoom into the open science part. And I think it is also a term pretty hot recently, but then also not fully understood by many of the people like engineers and researchers who are just many deep into the into the whatever development and the handling stuff. So this is a nice moment for you to share maybe the latest view and also what you think relevant for us. Okay, please go ahead with your presentation. I think we are the easy way that you just share the screen and we can kick off.
Yep. Can you see presentation?
Yeah.
Okay, so yeah, as Nico already mentioned, I am also a data steward at TU Delft. But in the mechanical engineering faculty, so you'll most likely be dealing with Nico more. And he said I know just as much about him, but he has been in the position longer, so I would argue he's definitely more of an expert. But I'm also here as the co-manager for the open science community in Delft. So that's why I'll be talking about the open science part. And so at this point, yeah, hopefully you've had all of these sort of technical agreements in place, you've had these discussions, and you're ready to publish your results, ideally openly. And I would also say this is a conversation that you want to start as early as possible and sort of give your intentions to partners that you would like to publish openly, and that this is sort of something especially we do at TU Delft, and as much as possible sort of give that preference while understanding that you also don't want to piss off partners. So start that conversation, but also accept what they're willing to do in that case. Yeah, so being as open as possible, I think, is sort of we talk about open science, but if we think about it, it's basically doing science, and having science done out in the open allows the scientific process to sort of proceed along the way it's supposed to do, which is why I have sort of the open in brackets. So within the Declaration of Human Rights, there is actually in Article 27 the statement that everyone has the right to freely participate in the cultural life of the community, to enjoy the arts, and to share in scientific advancement and its benefits. So it's actually written into the Declaration of Human Rights that society should be allowed to participate in this, and that can only be done if it's done openly. Traditionally, this has mainly been interpreted as open access to published results. And so looking at a little of the history of open access, we have 1991, the archive, so the popular preprint repository was established. Then later on, 2003, the Berlin Declaration stating that open access to that allows open access to knowledge in the sciences and humanities, which TU Delft was one of the signatories. And then another sort of milestone was this court case against Aaron Swartz, who was sort of passionate advocate of open access to all types of information, including scientific publications. It's actually a bit of a sad story. If, I recommend looking into it. Continuing on, so TU Delft has always been sort of at the forefront of open science, at least in the Netherlands, and sort of pushing what we can do as a university, along with Utrecht as well. So it was a really honor TU Delft policy on open access publishing. And then Plan S came in, which stated that we should move towards full and immediate open access, which then had some, to be honest, unintentional consequences, because it made it actually quite expensive for people to publish open access. But that was something that the publishers capitalized on, and we're sort of dealing with those consequences. In terms of open access in the Netherlands, we have the Peare amendment, which actually allows researchers at Dutch institutions to make their work open 6 months after let's say the article has been published, regardless of the policy of the publishers and of the open access status. So an article that is closed can be opened up after 6 months, or at least I think the actual amendment says after a reasonable amount of time, which has been interpreted as 6 months. So anything published, and then this can be a co-author at a Dutch institution as well. Yeah, and another quick note about publishers. As I mentioned, they capitalized on this movement towards open access, and that ended up being a lot more profitable for the publishers, which is problematic for science. But last year there was a court case, an antitrust lawsuit taken up against the main publishers in scientific publishing. So Elsevier, Sage, Springer, Wiley and Sons, Taylor and Francis. And this lawsuit claims that they have sort of colluded to create this oligopoly where people are sort of restricted in how they can communicate, how can they submit their articles, and all for extra profit. So it's something I personally follow with interest. So thinking, sort of moving beyond open access, because I think open access is just a very small part of open science, and also sort of, I would say, the least important parts, because in my mind, you have your journal article, and that's great. But if that is all you're sharing, so you have your text and final results, it sort of equates to advertising. You're advertising what you did, and you're sort of taking the reader through your narrative. It's like your narrative of the results and your narrative of what you did. So it is a kind of advertising. And so ideally, you are also releasing more than just the paper. So you'll have your narrative, but then you also release the data. And if you have codes that you use to produce the analysis and the results, and you've hopefully version control, so Nico already mentioned Git, then you move sort of towards the other end of the reproducibility spectrum, where you're actually, as the figure says, doing science, where this stuff is made available and it allows others to verify what you've done and potentially find mistakes. So a lot of mistakes are found later on, because we're human, we make mistakes. But the more people that are looking at what we did, the more people that can investigate what we did, the more likely we can find these mistakes, and then sort of allow science to proceed with its self-correcting mechanism that it's supposed to do. I mean, if we all just published articles without any kind of additional methods, then it sort of inhibits science's abilities to self-correct. Yeah, so a few years ago, and I think this was also a large part in the Netherlands, we sort of discovered there was a reproducibility crisis. I think this was mainly psychology, but I think it's also prevalent in other fields as well. And this was a survey that was done in a Nature news article, which ironically is not open access. But yeah, there's 52% of the 1,500 researchers that were surveyed agreed that there's a significant reproducibility crisis. And so if we're looking at what we sort of think of as reproducibility. What I mean when I say reproducibility is when you have the same data and you run the same analysis as the person whose study you're reproducing. This is often conflated with being replicable. But in this definition, replication is when you do the same analysis, but on a different data set. So you may have collected your own data and you do the same analysis, and you may or may not achieve the same results. If you don't achieve the same results, that's also interesting in and of itself. It doesn't necessarily mean there's foul play going on. If your study is robust, it means that you can someone else can use the same data, or you use the same data and run a different analysis and achieve the same results. And if it's generalizable, it means you can use different data, different analysis, and still arrive at similar conclusions. Yeah, so in order for something to be reproducible, you really need to be able to share the data in some way. Maybe it's not openly, but somehow you need to share the data with reviewers or with people who want to validate. So there was an additional study that looked at barriers to data sharing. So why don't researchers share their data? And yeah, the most common response was that it's not common practice in their field. And prefer to share data upon request, which is also problematic when it comes to the FAIR principles, which I'll discuss soon as well. So yeah, it was less so a question of data being complex or being too big or it's not suitable, and more just this sort of culture of not sharing, of being competitive and sort of not wanting others to be able to use your data. Yeah, so as I mentioned, the only way we can end this reproducibility crisis is by sharing our data and our methods. So sometimes it's not enough to share the data, especially if it's not well documented what you did. And generally speaking, the materials and methods section are not good enough. You're usually limited in word count, and you can't sort of show the exact procedures that you go through. So sharing code and software, experimental protocols is a much better way of doing this. And this can have benefits for yourself as well. It's not just a question of allowing others to see what you've done, but also the person reproducing your results or reusing your results may be yourself in some years. And so if you prepare your analysis and prepare your data for someone else to see, it's more likely it'll be much better documented for yourself in the future. Yeah, and some formatting issues with the slides. So some of the additional open science concepts. So there's open education as well, which is the one that you can't see up here, which mainly talks about open teaching materials, open textbooks, that kind of thing, because you want people to be able to access these educational materials without any, as it says, legal, financial, or technical barriers. Citizen science, I'm not sure if this will be relevant within the project, but including members of the public in scientific research, not just as, data collection vessels, but also as in helping them engage with the research process. Maybe they're even leading a research process with the support of researchers. And then open hardware, which is one of the flagships at TU Delft. And this, yeah, so open source hardware, so that these whatever it is, these computers or whatever can be modified and redistributed. Yeah, so the European Commission also has an open science policy, which is similar to most of these organizations, that they want scientific research to be open to society. And especially they've realized that the research is more efficient and productive when it's transparent. Let me see if I can change this. Yeah, so I'll show this instead since it's jumping
Yeah, sure.
around
But
this
this
page.
is visible. Yeah, nice. Yeah,
Yeah.
we can see it now. Yeah.
Yeah, so if you are interested in publishing something open access, you can usually check with your library if you have if they have agreements with publishers that allow you to publish open access without any charge. Sometimes this is written into the grant proposals, but a lot of especially the European universities have agreements with the major publishers. When you're looking to open your data, it's important to think about, how others will engage with these data. So making sure that they're fair, so findable, accessible, interoperable, reusable. And this is something that also Nico will be able to go into much more detail, or myself. But generally speaking, if they're findable, it means that they have a persistent identifier. It means you can search for them on Google and you'll be able to find them that way. And usually this is done by uploading to a trusted repository. For example, Zenodo was already mentioned. And in TU Delft, we have the 4TU research data repository. And these are all indexed by Google, which allow you to search for them. And they're all provided with a persistent identifier so that you can, so that the link doesn't, the website link doesn't break because someone decided that they wanted to change the URL or some other reason, or wanted to migrate to a different website. Accessibility is often conflated with open. So the data don't have to be open to be accessible, as long this is more related to the protocol or the internet protocol of downloading the data. So there has to be some sort of communication protocol in place that you can access the data. And so you can have a data set on Zenodo, which is in a restricted repository, but that will still be accessible. Interoperable means using open standards, open file formats. This, for example, using Python, R instead of MATLAB, using CSV files instead of Excel spreadsheets, which is a notoriously proprietary standard and a black box of how it actually works. And also using the standard terminology in your fields when you're working with data sets and naming variables and that kind of thing. And making sure that the data are reusable means that you have documented the data. Nico talked a lot about the context of your data, and this is important in the reusability. And also attaching a clear license. So making sure it's clear to whoever wants to reuse it so that they know how to reuse it. Opening methods. This means, for example, sharing your code in GitHub, GitLab, Codeberg, whatever other repository you might like to use or prefer to use. These on their own are not considered a trusted repository because they don't provide persistent identifiers. And for example, if you share a GitHub repo, it's actually quite easy to rename the GitHub repo, and then any hyperlinks you have to that repo will be broken. So both Zenodo and 4TU, for example, offer you to snapshot your repository, and then they will provide the DOI for that repository. Also, if you're sharing experimental protocols, computational protocols, there's a platform called protocols.io, which allows you to sort of really go into the detail about what you actually did, and sort of a step-by-step protocol that can be published, and it can be provided with a DOI as well. And the benefit of going these extra steps is that these can be considered as research outputs as well, and they can be cited in their own right. So it increases your impact. Yeah, so a little bit more detail about licenses whenever you're sharing data. Usually, if you're openly sharing data, usually we recommend a Creative Commons license. So you have the public domain designation, which just means that anyone can do anything with the data and they're considered public domain. Usually we recommend CC BY for data because this is minimally restrictive, but requires attribution. So someone, whenever they use your data, have to cite you. Technically speaking, if the data are in the public domain, you still have to cite the original source of the data, because otherwise that's considered plagiarism. But some people like to have this sort of extra legal security of requiring attribution there. And then you have increasingly restrictive licenses. So SA is share alike, meaning you have to use the same license. Non-derivative, you can't modify the data in any way. Non-commercial means you can't profit from the data. And then you have combinations of these extra restrictions. Software, similar. You usually want to choose a different license for software because these software-specific licenses will have references to source code and they're more appropriate than the Creative Commons. So for example, MIT is the equivalent of CC BY for software. And then you get increasingly restrictive, like the GPL licenses are equivalent to the share alike. So whenever you release codes with the GPL licenses, then anyone else that uses it have to also use a GPL license. Yeah, and so we're still in this sort of closed culture where we're not really sharing. And there's this movement towards changing this culture in the Netherlands with the recognition and rewards program at the national level, which TU Delft is participating in. And the idea is to sort of give credit for more diverse research outputs and more diverse contributions. Yeah, so mentioned a lot of things that you have to do and not really provide any advice on how to do this. So where do you start? Well, you can talk to Nico. He's also, he knows a lot about open science and how to actually implement these open science practices. We also have a community here in Delft, the open science community, which you can join and talk to other people who are passionate about open science and who have done this for years. Yeah, so some of the benefits of membership in the community is networking, learning new skills, increasing your impact, and also being able to inform what policies we're implementing at the ENSURE, sort of the direction of they're taking. And we're actually in the middle of the National Open Science Week, and we're having some events at TU Delft. So today, Nico is actually going to be hosting the panel discussion on knowledge security and open science. I think you may have to run if you want to catch that one, which is probably why he had to leave.
Yeah.
Tomorrow we'll be having a discussion about recognition and rewards for early career researchers, if that's something you're interested in. Thursday we'll have a networking event, and Friday is the Open Education Community Kickoff. If you search for TU Delft Open Science Week, you should be able to find the program and be able to register. Yeah, and so basically, if you want to know more, talk to Nico or to me or to the publishing people in the library, and they will know a lot about what you need to do. And they're always more than happy to help you. Yeah, so that's what I had.
Thanks a lot, Bjørn. I think the information you provided clearly somehow, tackle a couple of these questions, especially junior researchers might have when they started, navigating their publication, how to handle this open access. I think if you have questions from the audience or from online, feel free to write. And I also highly recommend, for Armand to attend the events because it's ongoing now this week on campus. And I think that's probably very useful. And then I have one personal question, maybe just to consult with you. Nowadays, I think if you are dealing with European projects, Zenodo is actually the go-to, but then is 40U actually the go-to for NWO projects? What's your current, your insights beyond on this? Yeah.
Yeah, I would say it's not funding specific. I'd say it's domain specific. So depending on what domain or depending on who your target audience is. So for example, the 40U is very much a natural and engineering sciences repository. So if you do want to reach that target audience, then I would recommend 4TU. Zenodo is more of a general repository that is pretty much globally known by now. So if you want to sort of expand your reach beyond engineering in the Netherlands, I would say Zenodo is a good option. But yeah, it really depends on your domain, and you can also look at where are others publishing their data.
And also we have our libraries here, and different universities. I know in Ireland, in Belgium, they have also the university library handling this part. How does actually this overlap with the Zenodo repository type of thing? Do we actually first go through the library and then put stuff on the Zenodo, or is actually you recommend to parallel?
Yeah, I mean, I would even say, I mean, there's no need to publish twice. Because you don't necessarily, I mean, you don't want to, because even with large data sets, you also have to think about sustainability, and you don't want to be taking up lots of hardware and cooling on
storage.
storing. Yeah, so I would say choose one. And then usually the university would like to know where you're publishing the data. So you'll have a system probably with the university where you can inform them of this. So for TU Delft, if you publish in 4TU, this is done automatically through the TU Delft system. So that is a benefit, that you don't need to do anything else once you publish there. But if you publish through Zenodo, usually they like you to update your the research portal. So
Okay, yeah, but I like the points. So essentially, they're not actually having just one paper or one document or one data set stored on multiple places, because then this is a huge replication and also resources for that. And I guess that the way you recommend is good. That, for example, if people place their original data on one server on Zenodo, but then all the other libraries just provide a pointer to that source, and then
exactly.
Yeah,
so that you'll be able to provide a link to the repository both on the university website, for example, or in your paper as well. So when you refer to, when you're in your data availability statements, you can use the DOI. It's important to use the DOI and not a regular URL. Because that ensures that when someone reads the paper in 5 years, that they can still navigate to the data.
Sure. Okay, thanks a lot. I think time-wise, you need to run. So let's maybe thank the speaker, and Bjørn, we will probably get in touch with you later. And especially for the PhD candidates we have in TU Delft, definitely they will have more engagement with you.
Exactly. And you mentioned training as well, and we're trying to implement actual open science training through the community. So yeah, it'd be great to put them in touch. So thank you.
Yeah, cheers. Bye-bye then.
Bye.